Okay, so in this section we're going to look at taking derivatives of products and quotients of functions. So we need to remember, let's review what we know about all of our derivatives, what we have learned so far, and then we'll introduce some new rules for products and quotients of functions. So first off, let's list all the derivatives we know. So we know that d dx of a constant is 0. We know the power rule, taking the derivative of x to the n is just n x to the n minus 1. We know that taking the derivative of e to the x is just e to the x. And lastly, taking the derivative of ln x is just 1 over x. And of course, we'll have correction factors for these if they're in a different base. But we'll not worry about that so much for now. And then we also know that multiplication by a constant and addition and subtraction, I'll write it up here, save some space. These carry through. So we just start writing them down and plug in the derivatives as we get to the functions. Okay, so today we need to talk about what happens when we multiply functions. So let's start with the product rule. And the product rule is just this. If you have a function, and I'm going to name it, let's say it's the multiplication of two functions. A first function and a second function. I know it seems kind of silly, except that a lot of times when we're actually doing this rule, we should be saying in our heads the following. The derivative is the first function times the derivative of the second, plus the second function times the derivative of the first. So notice there are two terms. When I multiply two functions, I get two terms. In each term, I take the derivative of one of the functions and not the other. Okay? So, and sometimes you can, so we will actually say that. You're going to hear me say in class, first times the derivative of the second times the derivative of the first. And in my head, I'm actually saying that when I write it down myself all these many years later. You can also kind of simplify this. Oops, I'm in trouble. That way. Sorry. So that just kind of simplifies it. We know what we mean when we write that. Okay, so let's come over here and add our product rule. I'm just going to write the derivative itself. So the derivative is the first times the derivative of the second plus the second times the derivative of the first. Okay, so that, let's go ahead and do an example of that. You're going to find that sometimes you have to use the product rule, sometimes it's just more convenient to use the product rule, and we'll get to more of those examples in class. But this is the one we'll do for now. So we'll have f of x equals 3x cubed minus 2x plus 1 times 4x squared minus 5. Okay, so I could, everyone agrees, we could multiply this out. That would be kind of a pain, but we could do that. And then once we've multiplied it out, we can take the derivative. Instead, let's use the product rule. If you were to do it either way, we will get to the same right answer. So just so that we are clear about that. So let's look at the derivative. I'm going to identify this and this. And if it helps you to underline pieces, please do that. So we're going to call this one the first function and the second function. So going along. The derivative is the first, so I'm just going to write that down, times the derivative of the second. 8x, so 4 times 2x, so 8x, minus 0. So this is one of the advantages of the product rule. We're going to end up having to multiply out anyway. There will be a lot of algebra with both this rule and the quotient rule. But the difference is once I've taken the derivative, I'm only multiplying by a single term. So it simplifies things. All right, so this is one term. First times derivative of the second. We are not done. So we need our second term, which which would be our second function, times the derivative of the first function. So 3 times 3x squared, 9x squared, minus 2 plus 0. And then we do need to multiply this out. All right, we'll go ahead and do that. So 8 times 3, 24, x to the 4th, minus 2 minus 16x squared, plus 8x. We're going to FOIL this one, so 4 times 9, 36, x to the 4th, minus 45, minus another 8, so that's what, minus 53, x squared, plus 10. I'm going to take a moment to make sure I did that correctly before I start adding everything up. Okay, and now we just collect like terms. So 24 and 36 is 60 x to the 4th, minus 16 minus 53 is minus 69 x squared, plus 8x plus 10. So that's your product rule. First times derivative of the second plus second times derivative of the first. And if you want to, what I didn't do that I probably should have is you can actually write this out. Give yourself directions. You don't have to carry this all in your head. Identify the first and second functions and then write first times derivative of the second plus second times derivative of the first. Give yourself some space, and then you know you've got all your pieces, because that tends to be where people have trouble, is they'll do this first one and think they're done and forget the second. Okay, so that's product rule. It's straightforward. It's just a little messy with algebra, so that just is what it is. All right, so now let's look at the quotient rule. The quotient rule is for a function in the following form. It has a top function divided by a bottom function. We could use numerator and denominator, but it just makes it kind of wordy. So the derivative is the following. The bottom function times the derivative of the top, minus. So there's a negative. Division and negative tends to go together. Multiplication and addition tend to go together. So that's, I'm thinking logs, I guess, so that's maybe one way to help remember. You have to memorize these, so just go ahead and get on it. So bottom times derivative of the top minus top times derivative of the bottom, all over, we all say that, all over the bottom squared. And again, we tend to write this shorthand, bottom times derivative of the top minus top times derivative of the bottom, all over the bottom squared. So again, when even me, I took calculus a really long time ago, I still say this in my head, so I encourage you to do the same. Let's come over here and write down our quotient rule. You will be happy to know there's only one more that we're going to add down here, and then we will have our completed list of derivatives. Is that true? Yes. All right, so this would be bottom times derivative of the top minus top times derivative of the bottom, all over the bottom squared. Okay, again, there's going to be a lot of algebra, a lot of manipulation, so just take your time, go through it carefully. With the quotient rule, sometimes we end up with interesting things that combine, so just look for that. So here is a function we'll do next. 2x squared over x squared plus 3. So we want to find the derivative. So again, we have top and bottom. So we're going to start with the bottom, work from the bottom up. So we're going to start with the bottom times derivative of the top, 2 times 2x, 4x, minus. And here's where I really encourage you, again, to use parentheses. We won't need to here, but in cases where you have, if this had 3 terms, so you had 2 terms in its derivative, please use parentheses until you've worked it all out. So bottom times derivative of the top minus top, 2x squared times derivative of the bottom, cubed x. All over the bottom squared, so x squared plus 3 quantity squared. So bottom times the derivative of the top, I'm just checking myself, minus top times derivative of the bottom all over the bottom squared. Okay, so now what we need to do is combine, multiply out combine like terms. So 4x cubed plus 12x minus 4x cubed, aha, interesting, divided by x squared plus 3 squared. 4x cubed minus 4x cubed, 12x over x squared plus 3 quantity squared. And I'll leave that there. There's another way to do this, so if you're interested after class, there's another way to I think we're not ready for that. We'll get to that in another class. Okay, so today we have covered product rule and quotient rule. You need to commit these to memory. You shouldn't even have to think about them, they just roll off your tongue. You should say them to yourself as you're doing the problem. It is perfectly fine to write out the pieces to make sure you get them all, and then be careful with your algebra. All right, that's it.